So it is essential in many industries such as automobile, aircraft, shipbuilding, packaging and sheet metal work, etc. Suppose boilers, chimneys are there, so other components are there. So the plates or sheet metal are cut to the development diagram and they are made to the desired objects. So like that in sheet metals, boilers, chimneys, funnels, bins, so these kind of objects can be made so by making use of development diagram. So methods of development, we have parallel line development and radial line development. So in parallel line development, solids like prisms, cylinder are solved. In radial line development, solids are like pyramid, cone are solved. When the surface of the solid is parallel to the axis of the solid, so parallel line development method is used. When the surface of the solid are not parallel, they are inclined to the axis of the object, radial line development method is used. So there is a simple difference between these two methods. So for regular solids, so it is developed. So in radial line development method, it is developed like these surfaces. So if it is, we'll see one problem. So which is a truncated cone. So whose diameter is 50 mm and height is 75 mm. So first we have to draw top view and so the same thing will be projected here. So this is the reference line. So this circle is this in the top view. It is divided into 12 equal parts. It should not be taken less than 12. So we have numbered here 1, 2, 3 like this up to 12. So the same points are projected in the front view. So since this is a truncated cone, so we have taken section plane, so and it is passing at the middle of the solid. The section plane is passing through the middle of the solid. I think that the solid is parallel, its base is parallel to HP, and a section plane is cutting the solid at midpoint of the solid, and it is making an inclination of 30 degrees with the horizontal plane. So this is the diagram. So we have taken 37.5 from the apex. So middle half of this distance height, and we have taken a section here. So we have 12 points here. So 12 generators. So the section plane cutting all the 12 generators will get 12 points. A dash, B dash, B1 dash, C dash, C1 dash. So like that. So in this problem, slant height we have to find by the formula under root r square plus h square. So this is radius and this is height. So with the values we have taken diameter 50 and height 75. We have got 79.05, and another formula is subtended angle theta. So it is given by this formula 360 degrees into radius of the base circle divided by slant height. So in this problem, so radius is 25 and height 79.05. So subtended angle we have got 113.85. So once we have found S, slant height and subtended angle, we can draw this diagram. So in radial line development method, so first we have to take center O, and yes, slant height is radius, and we have to draw an arc, and theta 113.85 is this portion, sector angle or subtended angle, and we have to divide this sector into 12 divisions. We have to divide this sector into 12 divisions. So since we have this circle 12 divisions in the top view, so we have to divide this into 12 divisions. So these points will get, so OA is nothing but O dash A dash, and this whatever the points that are there on inner generators, so that should be made, that should be drawn parallel to the base and onto the outer generator. So this point will be B dash, this point will be C dash. So O dash P dash is the distance we have to take, and O is center, and draw arc on this line, O2 line. So I have written here. So for the next point, so same, we have taken this line, and O dash C dash is the true length. So the same distance will be OC dash. So here take O as center, O is center, and take this distance OC dash and draw arc on this line. Draw arc on this line. So similarly, get other points D, E, F, G. Once you have finished this one, so the same procedure will be followed to the remaining half. So this is how we have to take the distances. So simple thing I can say, so the true length can be obtained directly to the outer generators, but for this inner one we have to take the distance parallel to the base and drawn to the outer generator. So that will be the true length. You can easily get points B, C, D, E, F, G, and A1, B1, C1, D1, E1, F1. So O is center, you have to take this length and draw arc on these lines O2, O3, O4, O5, so that you can get these points. So the surfaces, the diagram between this arc and this curve is the development surfaces of truncated cone. So this is how we will solve the problem of development of surfaces by the radial